Hey guys, what's up? In this video we're going to learn about theory of automata. So in our last class what we did was we knew that we have this formula over here, what type of fish it is and length of fish. Okay, so length of fish and multiplied by prior probability over total probability. Okay, so this is this is the speech recognition. A person known as Mr. Norm presented this idea in 1957, which is still used in speech recognition to this date. Okay, so what we have over here is, this is the probability of fishes of 6 centimeters in type A, which is equals to, the probability of, in computer we represent this formula like this, which is equals to the probability of fishes of 6 centimeters of type B. Okay, so how we're gonna solve this thing is, because see, if you want to take out the probability of, let's say, what type of fish it is and length of fish, so we know that as both fishes are of 6 centimeters, so we can say that the probability of A fishes that are probability of A into 6 such that a 6 centimeter fishes, type A fishes that are 6 centimeters, okay, over probability of A, and this whole thing can be cancelled out just because they're same. So this whole thing cancels out, and in the compiler we just write the simplified form. So we can say that probability of A is equals to probability of A 6 centimeter fishes plus the probability of type of B fishes, which is of type which are 6 centimeters long, and we can write the same thing as PB. And if you closely look at this is exactly the same thing. This I've done a mistake over here. Let me correct this thing. Because actually the bracket is right here and probability is outside of this thing. So let me just correct it. Okay, so in this class what we're gonna learn is about ambiguous grammar. Now what is ambiguous grammar? Grammar that is ambiguous. Now read carefully. एक बात को दो मतलब लेना. Ambiguous grammar means if you one like that my friend's birthday is coming, so okay, and my friend asks, hey Tala, if you want to come, then I reply to him or her that I'm gonna see. That now I am being ambiguous over here. I have told him or her that I may come or I may not come. So this thing is ambiguous. So just like that, grammar can also be ambiguous. In computer science, an ambiguous grammar is a grammar for which there exists a string that can have more than one leftmost derivation, while unambiguous grammar is a grammar for which every valid string has a unique leftmost derivation. Okay, so this is clearly stating that the same thing which I told you before. Okay, so now if we look at this thing, we have our production rules over here: sentence, noun, verb, object, and these are leftmost and rightmost. What he's saying right here is you start from non-derivation to complete derivation. You start from non-derivation to complete derivation. These are just production rules of a sentence. I am reading a book. Hold on a second. Now, if you look at a compiler does a top-down approach or a bottom-up approach. Okay. Now, top-down compilers must pay. There are from reads from the leftmost side, and bottom-up compilers usually learn from the right and the bottom, just like that. Now, these are your production rules, and we start from a non-derivative form to a complete derivative form, and the forms in between are called partial derivative form. Okay, So this is from slides. We have our example 1. E is a non-terminal and ID is a terminal. So E right here is non-terminal and ID is a terminal. So if you fit this code into your compiler, so it's gonna be an ambiguous situation because you're saying at the same time E plus E or E into E. This is an ambiguous situation over here. And now this is before this I forgot to tell you that this is a compiler type. Okay, you can Google about, and you can also Google about GNU/CC compilers which are used to compile C++ language. Okay, so coming back over here, where were we? Has E can be replaced by E plus E, and E can be replaced by E into E, and E is can be replaced by ID. Two different trees are possible for the same grammar. It means that one grammar has two meanings. The language dependent on such a language will be ambiguous language. Okay, now we have ambiguity types. There are two types of ambiguous. For some operations, the type of ambiguity occurs is the left and right association. Grammar should be left associative or right associative, but not both. A compiler should know your code should not be ambiguous. It should be left associated or right associated, but not both. So these are some of the theoretical things. Now, for different operations, like type of ambiguity occurs in the operation is the operation priority. Let's do an example of both. Now this is an example of an ambiguous statement. Now this is your left ambiguous situation over here, because after plus sign you have your E over here. Now look at this statement. Now if this E comes operation के बाद, right, if this E comes after this plus operation, then it is right associative, or the positives. If the E comes on the left, then it is left. So this thing will get cleared in a while. Just focus on what I'm trying to say over here. This thing will automatically get cleared. See, we have to follow BODMAS. If you're gonna just multiply first or add first or do what it takes, do all these procedures like let's say BODMAS says bracket of division, multiplication, addition, subtraction. Now if you're going to follow addition first, multiplication first, then division, or any other order which are the possibilities of this BODMAS situation, then our answer might vary. So we ultimately have to follow BODMAS to avoid ambiguities. Okay, now defining the priority level in grammar. The priority of operation is directly proportional to the depth of the tree or grammar. Now what do we have as our case 1? If we have only addition, these are a set of rules of production. Okay, so we're now setting the priority. We are taking addition as one case. E can be replaced by E plus T. Now E can be replaced by T according to this rule. T can be replaced by N. T can be replaced by N according to this rule. Now why we didn't take T into N? That is because we have a constraint that we have to do only addition. And N can be replaced by ID, and ID can be any value that is 6. Now in this situation, T can be replaced by N and N can be replaced by ID. Okay, now notice here also T can be replaced by N. This rule is followed, and N can be replaced by ID. This rule is sort of omitted just because we have the constraint that is we have to do only addition. Now okay, look at this case 2. E can be replaced by T. E can be replaced by T. See, according to this rule. And coming back to this, T can be T. Now the thing is that we have to apply only multiplication. Now according to these laws, we will apply only multiplication. We cannot use addition. So T can be replaced by N and can be replaced by ID, similar to this, and the answer will be 6 2s are 12. Comes back in here, and here in case 1, what our answer was 6 plus 2, that is 6 7 8. Case 3, only assignment rule. Now only assignment, that we cannot do multiplication or addition. So E is replaced by T. E is replaced by T. T is replaced by N. T is replaced by N. And N is replaced by ID. N is replaced by ID. Now notice we didn't use neither of the multiplication or the addition, because we have a constraint that we only have to use the assignment. Now case 4 is that we can use multiplication and pretty much your addition also. So E can be replaced by E plus T, E can be replaced by T, T can be replaced by N, and T can be replaced by T into N also. So where is the T into N, and T can be replaced by N, T can be replaced by N, and N can be replaced by ID, and the value of here is 4 2s are 8. 8 comes in here, and the value of this is 6. 6 plus 8 equals 14. Okay, जो लीफ के करीब होगा वो प्रायोरिटी है होगी. The one that is close to the leaf is the proper priority of that operation, or that particular operation in compiler is higher. The one that is close to root have lower priority. Okay, over here we have the defined priority for plus, multiplication and power. जिस पर जा रहे हैं उसकी priority high होगी. Okay, what we have over here is we have our set of rules. This can be called as A, B, C, and this particular rule can be called A1. E can be replaced by E plus T or T, and this can be called as A1. T can be replaced by T into F or F. F can be replaced by P power F or P. This I'll explain you in a bit. This is used for powers, this particular arrow thing, and P can be replaced by ID. Now what we have over here is, look at here. According to this rules, what would be the tree of this particular expression over here? 2 plus 4 into 9 squared. Hold on a second, let me just ease myself. E can be replaced by E plus T. E can be replaced by E plus T. Okay, now E can be replaced by 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 T. E can be replaced by E plus T and T as well. E can be replaced by E plus T and E can be replaced by T. Okay, T can be replaced by T into F and F also. T can be replaced by T into F and T can be replaced by F. F can be replaced by P and F can be replaced by P power F, and P can be replaced by ID. P can be replaced by ID and P can be replaced by ID. Now 9 is 81. 81 comes in over here, and 2, let's say this expression is 2 and this expression is 4. So whatever the answer comes in will be stored in this E on the above. So you're kind of getting the idea of what I'm talking about, what this situation is all about. It's about having these rules, making a tree out of it, of any given expression. Same goes over here. We are having these rules, and this is our expression 2 plus 9 squared. Now previous it's not 4 in here. Now in this expression it's saying 2 plus 9 squared. Now what we're gonna do is we have this set of rules. E can be replaced by E plus T or T. E can be replaced by E plus T. E can be replaced by T. E can be replaced by T. T can be replaced by hold on. T can be replaced by F, and F can be replaced by P according to this rule, and P can be replaced by ID. T can be replaced by F. F can be replaced by P into F, and P would be replaced by ID. F would be replaced by P and ID. Okay.